Hello, Maikako Kumui here. Thanks for your time and attention. This is going to be the first part of 4 for Unit 6 review. Okay, Unit 6 is linear equations and their graphs. So, before we begin, let's start with a joke. Why did the boy eat his homework? Because his teacher told him it was a piece of cake. Yuck, 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 yuck. All right, here we go. We're gonna go through all these questions. I'm actually gonna create new example problems for you, so you still have all of these review problems to practice on your own. All right, so this should help you out a lot in completing this and refreshing your memory. The first thing I want to talk about is rate of change. Whenever you see rate of change, you will see this term when you continue math. It's one of the biggest concepts in calculus is rate of change. Rate of change is simply synonymous with slope. The letter we use to designate slope, to denote slope, is usually m. That comes from the French for monter, to climb, which kind of makes sense, right? We climb things that have slope. Lines come in a variety of flavors. You see lines kind of going pitched in this direction, maybe a little even flatter, but same, rising from left to right. We always must read left to right. Okay, sometimes lines are falling from left to right. Sometimes they're completely horizontal, as in this case, and sometimes they're completely vertical. So to remember some classifications of slope and rate of change. The first image, case 1, these are positive slopes, okay, things that are growing as x moves from left to right. In case 2, these are negative slope. How do we remember that? One way to remember that is draw a capital letter N. If you can draw a capital letter N using all of these lines, which you can, okay, capital letter N, that's a negative slope, meaning as x moves from left to right, as x increases, the y values are decreasing. The y values are decreasing. In case 3, horizontal lines, just like if you were thinking about your driveway, there is no slope. If this were your driveway and you're driving your car through here, there is no slope. Now we have to be very careful because slope is a number. Slope is a number that describes the pitch or incline, and we use the slope of 0 here. It has 0 slope, this driveway. It's nice and neat. But if you encounter, in case 4, if you encounter a driveway like this, if you're in your car and all of a sudden you're trying to get into your garage but you see a brick wall, it's hard to classify. It's hard to even say what the slope of that driveway is. It's not even a driveway. Keep in mind, the slope of a vertical line is undefined. Now, there are reasons for this. Just to review really quickly, if we're talking about slope, there is a formula. There's 2 ways we can calculate slope. It's a change in y, yes, y, over the change in x. It's also equivalent to rise, which makes sense because you're moving up and down in the y direction. Rise over run. Okay, so one common mistake is to think that slope is change in x over the change in y, but it is not. It is the change in y over the change in x. So let's take a look at this. In a horizontal case, if you do the change in y, you're taking -4 minus, I should write the formula actually. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There is no second point and first point. You just need to go in the same order. All right, so that's how we calculate slope. So for this example, we would have the slope is -4, which is, let's start with this one, okay? Is -4 minus -4, because that's the y value of this point. And we have -5 minus a 3, okay? If we recall, subtracting a negative is like adding a positive, so we have -4 plus 4, that's 0, and this is -8. 0 divided by anything is 0, so that justifies that the slope of a horizontal line is 0. Furthermore, if you are moving from, another way we can think about that is if you're moving from this point to this point, there is no rise. So the rise, if you're thinking slope is rise over run, which it is, there is no rise between the 2 points, and there is a run of 8, or -8 if you're moving left, or 8 if you're moving right. In either case, the slope is 0. Now, if we apply the same formula for slope to this, Let's use this as our first values. We have 3 minus a negative 4, okay, because that's this y value minus this y value. And we need to go in the same order, so we do 5 minus 5. In this case, it didn't really matter, but we were doing this 5 minus this 5, same order. So we have 7 over 0, and one of the cardinal rules in math is that you can never divide by 0. This is undefined. There are numerous reasons why we can't divide by 0, but we don't want to get into it here, okay? There's very good compelling reasons. Just ask me and I'll explain. So that's a rundown of slope. We've got case 1, positive, case 2, negative, case 3, 0 slope, case 4, undefined, okay? Next, find the slope. Well, you know, actually, I hope I gave you some review on that already. But if you need it once more, let's do it real quickly. We've got points plotted, 2, negative 4, and negative 1, 2. We want to prove slope 2 different ways, okay? And I'll show you. One, we've already talked about the formula. So if this were the problem we were doing, it's a brand new problem, you could do 2 minus negative 4 over negative 1 minus 2. Make sure you go in the same order. This is going to be subtracting negatives like adding a positive, so we've got 6 over negative 3. We need to simplify that. It simplifies to negative 2. Look at the graph. This confirms that the slope is negative. Note, you can also go the other direction. You could do this minus this. Just got to maintain the right order. So you have negative 4 minus 2. That's the change in y. And the change in x is 2 minus negative 1. Notice what happens. This is negative 6 over positive 3, which amounts to negative 2. So have confidence you can go both ways. Notice you can also calculate slope graphically by doing rise over run. Let's say we're moving from this point to that point. The rise would be 1, 2, 3, 4, 5, 6. The rise is positive 6, and the run, which goes on the bottom, is 1, 2, 3. Negative 3 because we're moving left. The slope is negative 2. Now note, we could also be moving, who says we have to move up from point to point? Let's move down from this point to this point. So the rise would be, we always want to do rise first. It's rise over run. It's 1, 2, 3, 4, 5, 6. But negative 6 is the rise because we're going down. And a run of 1, 2, 3. Positive 3. Notice it doesn't matter how you do it. You're going to get a slope of negative 2 no matter what. And that's the beautiful consistency in math. Okay, so let's talk about how to graph. This is change each equation into slope-intercept form if necessary. Sometimes it ain't. Sometimes if it's in slope-intercept form already, we thank our lucky stars because it'll be nice and easy to graph from there. It's always a good practice to identify the slope and the y-intercept because you only need those 2 pieces of information to graph any single line in the universe. Lines are very simple. They have a slope and a y-intercept, and those are basically the 2 properties. Okay? So here's an example problem that I want us to do. Y equals 3x minus 2. Slope-intercept form, let's review. Y equals mx plus b. This is slope-intercept form. Okay? M is the slope. That is where the slope is coded, and b is the y-intercept. This is where the y-intercept is coded. Now, that makes sense. I'll explain that as I move on in this problem, but let's just look at this line and try to graph it. The slope, if you said the slope is 3, you are correct. We want to write that as a fraction, 3 over 1. The y-intercept is negative 2. So, knowing these 2 pieces of information, that's all you need. You're going to go down to the y-intercept. It's not the x-intercept, it's the y-intercept, and a slope of tree. Now, a slope of tree, remember, this is the rise. This is the run. If we go positive 3 rise, 1, 2, 3, and a run of 1, that puts us here. Notice you can also do a rise of negative 3 and a run of negative 1. Negative 3 divided by negative 1 is still positive 3. What would that mean? A rise of negative 3 is going down. 1, 2, 3. And a run of negative 1 is going to the left. 1. So that puts you here. Notice, again, the beautiful consistency of math. Okay? And that's your line there. Why it doesn't go directly through all of those, I think the graph is a little distorted, but you would get full credit for that. Let's come back to why, really briefly. Why is this the y-intercept? Sorry to be ironic, but it's because when x is 0, if you plug in a 0 there, you'd have 0 minus 2, and that happens to be the y value. Y value would be negative 2. Hence, that's the y-intercept. This is the y-intercept, not the x-intercept. Okay? Let's do one more problem. And yep, we're almost done with the graphing section. So let's do a problem like, have I included a problem? Yeah, okay, fine. Let's do another problem. Nice and snappy. We've got y equals negative half x minus 4. Do not be intimidated by all the negatives and do not be intimidated by the fraction. Fractions are our friends. Why? Especially when it comes to slope. We have a slope of negative 1/2 and a y-intercept of negative 4. It's always good to identify these two pieces of information now. In thinking about the slope, when you have a negative 1/2, it's good to split the negative into one location. And it really only does need to go into one. Because if you look at this, negative 1 over 2, that's negative 1/2. And if you have a positive 1 divided by negative 2, that is still negative 1/2. This is going to come in handy in our understanding. So let's graph this puppy. We're going to go with a y-intercept of negative 4. 1, 2, 3, 4. And we need a slope of negative 1/2. Now, you can conceptualize slope as this slope of negative 1/2 as a rise of negative 1 that goes down and a run of positive 2. That's to the right. Bang. Or you can think about slope this way. Okay, you can resolve the slope as positive 1 rise, which is up, and left 2. 1, 2. Notice the beautiful consistency. These 3 points are indeed collinear. Okay. I think I could have did a, I'm going to see if I can move that. Nope. I'm going to redraw that. So it's going to go through here, here, and there. Much better. Okay? And you want your line to be longer, use your ID card or a ruler at home to graph it nicely. Sometimes we're not given a line in the form we want. The form we want for graphing is typically slope-intercept form. Slope-intercept form, y equals m, the slope, plus b, the intercept. Sometimes it's not, but that's okay. Let's roll with it. We know how to convert from, this is standard form, where x and y are on the same side, to slope-intercept form. So let's begin. Let's get the x's on the other side. Do we do it that way? Is this the problem I want to do? Let me adjust this problem a little. Let me go, let me change this, problem a little. Let's go 2y plus 5x. Sorry, adjusting on the fly. 2y plus 5x equals 6. Okay? So you're going to get the x's on the other side. So we have 2y equals negative 5x plus 6. Okay, by subtracting 5x from both sides. Next, we divide by 2 to isolate the y. So we have y equals negative 5 halves x plus 3. Why 3? Because everything on the right side needs to be divided by 2. All we have to do now is graph that. The slope is negative 5 halves. Don't be intimidated. We want that. And we have a y-intercept of positive 3. Okay? Now, so when it comes time to graph, let's use orange. We go up 3, bang. And we need a slope of negative 5 halves. Again, you could think about this as negative 5 over 2 or 5 over negative 2. Either way, just make sure your line is sloped in a negative direction, negative orientation. Make sure you don't go that way. By going up 5, right 2, that would be a big mistake. Okay? So we go down 5. 1, 2, 3, 4, 5. And if we went down 5, we got to go to the right. Don't go to the left, because that makes a positive slope line. Or we go up 5, 1, 2, 3, 4, 5, and to the left 2. Okay? Because it's positive 5 over negative 2. And there you go. That's how we graph this line. All right. Yep. so I did change the equation, but that is the correct graph for that equation. Alrighty, make sure you just get y by itself. Lastly, there's one more way to graph, and that's using X and Y intercepts. So let me explain that. This is our example problem. What if we were trying to graph 3x plus 4y equals 12? Put your answer in coordinates. That's one important detail we want to think about. Then graph using the two intercepts. Okay. Here's a little doodle I love to make to myself to find X and Y intercepts. I hope it helps you. I do it every time. This is an x-intercept. This is an x-intercept. This is an x-intercept. What makes the x-intercepts important is that they all share something in common. What do they have in common? Their y value, look at all those 3 points in circle. Their y value is 0. Bang. That's going to be key. Okay? Now let's look at these y-intercepts. That's a y-intercept. That's a y-intercept. That's a y-intercept. So what do y-intercepts have in common, and what's important about them? Well, it's the complete opposite. Their x value is 0. Okay, and that is our key. Just making this little doodle should help you a lot. So let's say we're trying to graph this. Well, to find the x-intercept, oops, that should be a hyphen. To find the x-intercept, looking at our doodle, looking at our key here, the y value is 0. And you solve for the x. Okay, so you simply plug a 0 in for the y. Okay, and you get 3x equals 12, and you get a y value, an x value of 4. Now to find the y-intercept, it's the complete opposite process. Okay, we know at y-intercepts, look at this green, that's another y-intercept, that's another y-intercept. The x value is 0, so you plug in x is 0, and you solve for the y, and you get a y value of 3. And then you simply graph these 2 points. We've got 1, 2, 3, 4. And 0, 3, and voila, that is your line. Okay. Now, we should always double check this just to be careful. And this is the beauty in math, the beautiful consistency. Let's put it in slope-intercept form. Why? Just for kicks and to double check our graph. If we divided by 4, we would get y equals -3/4 plus 3. Is that this line? Well, yeah. Is the y-intercept 3? Yes, it is. Is this... Oh, I missed an x, didn't I? Bang. Is our slope -3/4? Well, let's see. Is it negative, first of all? Yes, it is a negative. Because it's pitched this way, capital letter N. And we go down 3. That's the rise. 1, 2, 3. And a run of +4. 1, 2, 3, 4. So that is the line. That concludes the first part. Guys, thank you very much. Work hard. Mahalo. Ask me any questions.